So in this video, we are going to discuss about bandpass filter. We know that there are two types of bandpass filter, which we have already uh, discussed, which is based on the figure of merit or quality factor Q. Whenever the Q value is less than 10, it is called as wideband pass filters, and the Q value is nothing but F naught divided by bandwidth. Bandwidth, we know the formula, right? Bandwidth is nothing but FH minus FL, where F naught is your central frequency, which is root of FH F8. Okay. So now let us discuss about wideband pass filter. So it can be formed by cascading the low pass and high pass filter. Okay. It is formed by cascading. First, we have to cascade the high pass filter with and low pass filter. So how it will look like if I want to construct the low pass filter, high pass filter. High pass filter will look like this, right? This is my high pass filter. So let me take this is 0.01 microfarad, and this one has 15k, 1.5k, right? And it is connected to a positive terminal of the opamp, and this is for your gain, right? This is my RF and R, and it is grounded. So this is your first order high pass filter, right? So this must be cascaded with your low pass filter. So low pass filter is alternation of these two values, right? So instead of capacitance, you have to connect a resistor. Okay. So here the resistance values. So here resistance value is nothing but 15k, and this is 0.01 microfarad, and it is connected to a positive terminal of the op-amp, and this will contribute for the gain, right? So this here V naught or 1 naught. Okay. So what is this one? This is nothing but your first order low pass filter. So we know the gain of the first order high pass filter, right? So that represent as h of 0, that is nothing but a1 divided by root of 1 plus f divided by fl the whole square into f divided by fl. So this I can write it as a1, where fl value is nothing but 1 divided by 2 pi of 2 pi rc, right? So here the rc values r values 1.5k, and c value is 0.01 microfarad. So on solving, you will get the answer. Value is nothing but 1 plus rf divided by r, right? So this I can write it as 1 plus rf divided by r, okay, into f into 2 pi rc, root of 1 plus f 2 pi rc the whole square. So the where h naught is nothing but 1 plus rf divided by r into j 2 pi frc divided by 1 plus j 2 pi frc. This is for high pass filter. So similarly, if I go for the low pass filter, so let me take this one as f0 of 1. Okay, 0 of 1. And similarly for the low pass filter, I can write it as a naught of 2. Okay, divided by root of 1 plus f divided by FH the whole square. So this and all we have already derived. Okay, this is 1 divided by 2 pi RC, where this R is nothing but 1.15K, right? So this is 15K into 0.01 microfarad. So where A naught of 2 is nothing but 1 plus RF divided by R1, okay, divided by root of 1 plus F divided by F kit square. So here the overall gain, since I have cascaded this value, so I will get the overall answer, that is F naught divided by F in. This is nothing but multiplication of these two values, that is A naught 2 divided by root of 1 plus F divided by F h square into A naught of 1 into F divided by FL into 1 plus divided by 1 plus F divided by FL the whole square, right? So you can write this is nothing but A naught, where A naught is nothing but A naught 1 into A naught 2. Okay, so you will get the final answer as this. Let us now discuss about one problem based on this values. They are asked to design the wideband bandpass filter, and they have given the value of FL is equal to 400 hertz and FH is equal to 2 kilohertz. Okay, and the passband gain of the passband gain is, that is A naught. The passband gain A naught is equal to 4. Okay, they are asked to find the value of Q. So you know that the formula, right? Q is equal to F naught divided by bandwidth. So F naught is nothing but root of FH into FL, and this is nothing but FH minus FL. So if you solve, you will get 2 into 10 power 3 into 4 into 10 power 2, right? Divide by 2000 minus 400 is 1600, right? So on solving, you will get the answer as 0.56. So since the value is less than 10, so it is nothing but a wideband burst speed. And it is having a roll-off rate of minus 20 dB per decade, right? So if I cascade the 2 second order the low pass and high pass filter, I will get minus 40 dB per decade. So